Hi. Hello. Welcome back to our mathematics video class. In the previous video, we gave a brief introduction of sets. In this video, we are going to discuss the different types of sets. Please share our video to your friends. Also support us through like, comment your suggestion. Let us move on to the topic.
Hi. Just consider the set A is equal to set of all x, such that x is a student of class 11 presently studying in the school. In the set A, we can include the names of the students who are currently studying in class 11 presently. Now consider another set B is equal to set of all x, such that x is a student presently studying in both classes 10 and 11. Is that possible? Think. Yes. It is not possible. Therefore, set B has no element. Such type of sets are called empty set or null set. Here is the definition of an empty set. A set which does not contain any element is called the empty set, or the null set, or the void set. The empty set is denoted by the symbol phi, or an open-closed braces without any element.
Now consider the set A is equal to set of all x, such that x is a natural number and 3 less than x less than 5. From this set, we can write it as set A is equal to 4. That means set A having only one element. Such type of sets are called singleton set. The definition of a singleton set is a set which has only one element is called a singleton set. Now consider this set V is equal to A, E, I, O, U. In this type of sets, we can calculate the total number of elements. Here the total number of elements in set V is 5. Such sets are called finite set. The definition is a set which is empty or consists of a definite number of elements is called a finite set, otherwise the set is called infinite set. Some examples are as the set of family members, finite set, the set of indoor-outdoor games you play, finite set, the set of all points on a line, infinite set.
Now, we looking for another term, cardinal number of a set. Cardinal number is nothing but the total number of elements in a finite set. That means we count how many non-repeated elements in a finite set. That is, when a set is finite, it is very useful to know how many elements it has. The number of elements in a set is called the cardinal number of the set. The cardinal number of a set A is denoted by NA. Now, let us consider the following sets. Set A is equal to 1, 2, 3, 4, 5 and set B is equal to 6, 7, 8, 9, 10. Here, the two sets having different elements or members, but the number of elements in A is equal to the number of elements in set B, that is, n of A is equal to n of B. So, in short, two finite sets A and B are said to be equivalent if they contain the same number of elements. It is written by the equivalent symbol. If A and B are equivalent sets, then n of A is equal to n of B.
Now, consider the following sets. Set A is equal to 1, 2, 3 and set B is equal to 2, 2, 1, 3, 3. Here, set A has 3 members, namely 1, 2 and 3. In set B, 2 and 3 are repeating. So, we consider it only ones. Hence, set B has also 3 members, namely 1, 2 and 3. From this, we can clearly observe that set A and set B has 3 members and all the members in the both sets are equal. These type of sets are called equal sets. In general, given two sets A and B, if every element of A is also an element of B, and if every element of B is also an element of A, then the sets A and B are said to be equal. Clearly, the two sets have exactly the same elements. Note that a set does not change if one or more elements of the set are repeated. That is why we generally do not repeat any element in describing a set.
A universal set, denoted by U, is a set that contains all the elements relevant to a particular problem or discussion. It is like a comprehensive container for all the elements being considered. Please go through the following examples for better understanding. If we discuss about elements in natural numbers, then the universal set U is the set of all natural numbers. If set A is equal to Mars, Earth, Jupiter, then the universal set U is the planets of solar system.
Consider the following two sets. Set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set B is equal to 5, 6, 7. Look on the two sets. Here, all the elements in the set B is also present in set A. That means B is a subset of A. In general, a set A is said to be a subset of a set B if every element of A is also an element of B. We can represent it by the subset symbol and read as A is a subset of B. If A is a subset of B, if A is an element of A, implies A is an element of B. This can be written as symbols as follows. If A is not a subset of B, we write a not A subset of B. Now, can you say what about the number of elements of set A and set B? If A is a subset of B, yes, the number elements in set A is less than or equal to number of elements in set B.
Now, we are moving on to subsets of set of real numbers. We know that R is representing the set of real numbers. There are many important subsets of R. Some of them are the set of natural numbers N, the set of integers Z, the set of rational numbers Q. The diagram gives you a clear picture about the subset of real numbers. In rectangular box contains all the elements of real numbers. Inside the rectangular box, all the circles, which are the subsets of the real numbers, like rational numbers, integers, whole numbers, natural numbers, irrational numbers.
Now, we are moving to a very important concept, that is, intervals as subset of R. Let A and B are the elements of R and A less than B. Then, the set of real numbers we can write set of all Y such that Y is a real number and A less than Y less than B. And this is called an open interval and is denoted by A, B. The intervals put in a bracket. Here, all the points between A and B belongs to the open interval A, B. But A and B themselves do not belong to this interval. The intervals which contains the end points also is called closed interval and is denoted by square brackets. A, B. That is, closed interval A, B is equal to set of all x such that A less than or equal to x less than or equal to b. There are intervals closed at one end and open at the other end. That is, set of all x such that a less than or equal to x less than b. In this case, it is an open interval from a to b including a but excluding b. And set of all x such that a less than x less than or equal to b. In this case, it is an open interval from a to b including b but excluding a. The figure gives you a clear picture about all types of intervals.
That is all in this video. Thank you for watching this video. We will come back with next video, and the topic covered in the upcoming video is Venn diagram and operations of set. Please comment your valuable suggestions. Also, share this video to your friends. Do not forget like our videos. Stay tuned for next video. Once again, thank you. And we are signing off now.